Good afternoon or evening, AP Calculus students. So this is going to be my video guide / answer key, basically, or answer key for the Unit 2 study guide or review packet. All right. Now, the topic we are covering in this one is going to be differentiation and properties of derivatives. If you need a blank packet for this, feel free to find me. I do have extra blank copies. If not, as you are doing this or redoing, ideally you're redoing this, right? Use this as to help you redo each of the problems. Obviously attempt the problems yourself first. All right, let's just jump in to each problem. So the first one right here, AP problem number 1. F of x is equal to natural log of 4x minus 7 for when x is less than 2, and 4x minus 7 for when x is greater than or equal to 2. For the function defined above, which of the following statements about f are true? Well, let's see. The limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. The limit as x approaches 2 from the left of the derivative and the limit as x approaches 2 from the right of the derivative are equal, and f is differentiable at x equals 2. Well, cool. Well, the first one, I'll say item 1. Let's see if that is true. So the limit from the left, I'm going to plug it into my left function. So I'm going to plug it into this function. Right, so that's going to be ln of 4. Instead of x, it's now going to be 2 minus 7. And we're seeing if that's equal to 4 times 2 minus 7. So how does that turn out? That turns into ln of 1 is equal to 1. And what is natural log of 1? Well, natural log is base e, right? So this is really saying e to my answer is equal to 1, right? And e to the what is equal to 1? Well, to get something equal to 1 as an exponent, it would be e to the 0. So ln of 1, this is actually going to be 0. This is 0 is equal to 1. So number 1 is false. It is not true because 0 does not equal 1. All right, number 2, statement 2, the limit from the left of the derivative is equal to the limit from the right of the derivative. Well, let's take my derivatives. So the derivative of ln of 4x minus 7, that is 1 divided by 4x minus 7. And I'm going to multiply. Notice this requires a chain rule, right? Because I have an outside ln of 4x minus 7, and then the inside is this inside function is 4x minus 7. I multiplied by the derivative of that, so I multiplied by 4. So review your derivative rules if you do not remember this. Remember, I'll just type it out, chain rule. I take the derivative of the outside while leaving the inside and multiply by derivative of the inside, right? Okay, so that's my left function. My right function is going to be the derivative of just 4x minus 7. That's 4. Excellent. Now the limit from the left, that means I'm going to plug in 2 into my derivative, which is right there. So it's 1 divided by 4 times 2 minus 7 times 4 is equal to 4. And that is going to be 1 over 1 times 4 is equal to 4. And that means 4 is equal to 4. So statement 2 is true because, so I'm going to say this one's false, this one's true, because the limit from the left and the right are equal to each other. All right, finally, let's go on to statement number 3. And here's where we take some notes on what differentiable means. So it says f is differentiable at x equals 2. All right, so notes on differentiability. What does it mean for a function to be differentiable? Well, I'm going to say it's similar to continuity. All right. First, for a function to be differentiable, it must be continuous. All right, so it has to be continuous. That's a requirement. Second, unlike continuity, where if you remember the limit definition for continuity, it is, if you remember this from yesterday, it is the limit as, the limit as x approaches, let's say, a value from the left of a function must equal the limit as they approach from the right of a function, and it must equal the exact value of a function. Well, similar to differentiability, you just replace everything with the derivative. So actually, so basically the limit from the left of the derivative of the function, so f prime of x, must equal the limit from the right of the derivative of the function, f prime of x, must equal the derivative, right? Basically what this is saying is that the derivative from both sides must be equal. That is the definition for differentiability. It basically means, can you take the derivative? The derivative from both sides must be equal. In contrast, continuity is simply the function from both sides must be equal. So they're similar. You can see continuity, the function from both sides, they have to sort of meet and be connected. Differentiability, the derivative of both sides have to meet and be connected. So is that the case here? Well, we actually sort of tested it here, right? Because I took the limit from the left and the right of the derivative, and we said 4 equals 4. So 3 is also true. My answer choice is going to be C. Right? It is differentiable. All right. There we go. All right. Let us go on to the next step. All right. Next problem, the graph of a function f is shown above. At which value of x is f continuous but not differentiable? All right, so yes, continuous, no differentiable. All right, well, yes is continuous. So let's point which points are continuous. Okay, so A here, the limit from the left and the right, basically it's all connected. I don't have to lift up my pencil to draw it. So A is continuous. So I'm going to put a check mark with A. B is not continuous. C is continuous. D is not continuous. That's a jump discontinuity. And E is continuous. All right, so I'm between E, C, and A. Okay, so we figured out the points that are continuous. Okay, it cannot be differentiable. And what does differentiable mean? Again, it means I can take the derivative. And it means the derivative from both sides is equal. All right, the derivative, or you could think of this as the slope from both sides, is equal. And if you look at our notes, there's certain cases where that's not the case, right? Non-differentiable functions. You'll notice the slope here is not equal to the slope here. So non-differentiable points include like sharp corners, vertical lines, right? This right here, this slope, I can't really take the derivative of that because that's a vertical line. So that would be an undefined slope, or discontinuities, right? So those are non-differentiable points. Well, let's see which one of these is not differentiable, because I'm looking for when it's not differentiable. All right, A, this is a sharp corner, so it's not differentiable. This is actually going to be our correct answer, right? Because it's both continuous and it's not differentiable. So it's continuous, but not differentiable. All right, let's just check C and E. Well, c is differentiable. You see from both sides, the slope begins to be the same, right? From both sides, the slope starts to look like this. It is a smooth curve, so it makes sense that the slopes are the same. And e, the same deal. It is a smooth curve, so from both sides, the slope starts to be the same. All right, that's our answer choice for that. Finally, let's read this question. Let f be the function given above. What are all the values of a and b for which f is differentiable at x equals 2? Okay, so if it's differentiable, it must also be continuous. And let's remind ourselves of what that means, right? So for continuity, the limit from left and right must be equal. And the exact value must be equal. Okay, differentiable. The limit of the derivative from the left and right must be equal, right? Those are our two things. So let's test that. So first, what are the values for a and b for which f is differentiable at x equals 2? So if it's differentiable, it must be continuous. So these two functions have to be continuous. That means the left function, so x plus 2b, must be equal to ax squared, right? And it must also equal the exact value, which is also x plus 2b. So that's sort of redundant. I'm just going to erase that. Okay, so that's one equation. I also know it's differentiable, which means the derivatives must be equal. Well, what's the derivative of x? Derivative of x is 1. Derivative of 2b. Well, 2b is just a number, actually, right? B is going to be some number. So the derivative of 2b is actually just going to be 0. So I say 1 plus 0 is equal to the derivative of ax squared. Well, if a is some number, ax squared, that's just going to require a power rule. So when I do power rule, it's going to be 2ax to the first power. Right, so let's simplify that equation. It's 1 is equal to 2ax. Cool, this is nice because I have two equations and two unknowns to solve for. This is basically a systems of equations problem now that you might get on like the SAT or that sort of stuff. So let's solve for this stuff. All right, well, what do I know? I know also I have two unknowns, which are a and b, but I know x is 2. So I can change these equations. This equation is actually 1 is equal to 2a times 2. So it's actually 4a. Right? Okay. X plus 2b, so 2 plus 2b is equal to ax squared. So that's 4 times a, right? Because x squared is 4. All right. Now I can really treat this as a systems of equation problem. And I'm going to use substitution. What I'm going to do is solve for a. So a in this case is equal to 1/4. Great, that actually allows me to eliminate some answer choices, right? It's not going to be D, it's not going to be E. A is clearly going to be 1/4. All right, if A is 1/4, I can plug 1/4 into A right there. So this turns into 2 plus 2B, 2 plus 2B is equal to 4 times A is 1/4, so that is 1/4. Okay, so 2 plus 2b is equal to 4 times 1/4 is going to be 1. 2b is equal to 1/2. And that means b is equal to, 2b is not 1/2. 2b is -1. And that means b is equal to -1/2. All right, hopefully you can follow my line-by-line work. Each line is connected by an arrow. All right, so A is 1/4. When I replaced in A into my other equation, I solved and got B is equal to -1/2. So my answer choice is going to be A. All right, hopefully that makes sense. Let's go on to our next question. Cool. So our next question concerns the average rate of change. So a zoo, you can read the question right here. So average rate of change, usually when they ask us to approximate the rate, that's an average rate of change question, AROC. So average rate of change, the equation for that is f of b minus f of a over b minus a. All right, in this case, I want to estimate at 6, right, at t equals 6, which means when they ask you to estimate at 6, that means you're going to choose the numbers close to 6. So I'm going to use 5 and 7 to estimate it. That would be my best estimate, right? I could use 2 and 8, but those are less accurate because they're further away from 6, right? So I want to use 5 and 7 to estimate the rate of change at 6. So it's going to be 7 minus 5, f of 7 minus f of 5. That is equal to, well, 7 minus 5 is 2. F of 7 is 21. And I got that from my table here, right? F of 7 is 21. F of 5 is 13. So 21 minus 13 divided by 2. 21 minus 13 is going to be 8. So 8 divided by 2. So that's equal to 4. And I want you to have the units here. So they give you the units. The units is the change. Remember, so 4, the units for y over the units for x. Well, my units for y is hundreds of entries. So 4 hundreds of entries. The units for x is hours. So you don't have to actually overthink units, even if they didn't tell you. You just put your units, it's change in y over change in x, right? Over x. So you just put your units for y and your units for x. My units for y is hundreds of entries. My units for x is hours. That's my answer, is 400 per hour. I want you to write out the units here, so you can write out the units. All right, let's move on to our next question. All right, here we are applying the limit definition of the derivative. I'm going to circle that and just leave that written there. Okay, and let me explain that here. The limit definition of a derivative. So here's my hint. Anytime you see a limit with h going to 0, know that even though the limit looks complicated, really, they are simply asking for the derivative. Asking for the derivative of f of x, right? That's all they're asking for. So here, although it's the limit as h approaches 0, let's not overthink that. Really, they're asking for the derivative of f of x. So I could erase this problem and basically say, what is f prime of x? Right. Okay, so what is f prime of x? Well, first of all, the way this function is written, all right, I can match this up with my limit definition of a derivative and see first what is f of x, right? Because I can find my f of x, then find the derivative. All right. So I'll notice that my f of x plus h, f of x plus h is written as 2 plus h to the 5th power. You'll see how that these two parts sort of match, right? This f of x plus h and 2 plus h to the 5th power, they match. Right. Well, what does this tell me? This tells me my x is equal to 2. Right, you can see x plus h, 2 plus h. And also, what does my function do? Well, my function puts it to the 5th power. So my f of x is really putting whatever I have in there to the 5th power, so x to the 5th. All right. So this actually helps me answer my question. So my f of x is equal to x to the fifth. So that's my answer choice B. And it's asking me for my derivative, right? Remember, what is my derivative? F prime of x. Well, it's actually now x is 2, so it's f prime of 2. Right, so it's answer choice B. Because I'm trying to find f prime of 2, which is what answer choice B says, where f of x is equal to, as I said here, f of x is x to the fifth. So just so you know, if I were to actually solve for the limit, it's simply going to be the derivative, right? And if the function is x to the fifth, my derivative is 5x to the fourth. I know x is 2, so it's 5 times 2 to the fourth. 2 to the fourth is going to be 16, so it's 5 times 16, which means my answer here is 80. So actually, I could solve for what this is equal to. It's equal to 80. And I bypassed doing all this weird h of 0 stuff. I just know it's asking for the derivative, so I know my answer is 80. All right, next question. Same structure here. So based on I want you to try to match it up with this, but based on what I know, x is going to be equal to 1/2. F of x is going to be equal to 8x to the 8th power. And you can see that here. Every time there's a f of x function, what I seem to do with it is I put an 8 in front of it, so I multiply by 8, and also I raise whatever's in the parentheses to the 8th power. Cool. And they ask me to solve for the limit. Solve for the limit. In this case, is the same as solving for the derivative, right? Remember, that's what this limit is asking for, so that's why not to overthink it. This limit looks complicated, but again, they're just asking for us to solve for the derivative. Well, what is the derivative of f of x? The derivative of f of x is f prime of x. That's equal to 64x to the 7th. That is via power rule, right? Then I plug in 1/2, so f prime of 1/2 is equal to 64 1/2 to the 7th. All right, here, hopefully we'd be decent-ish with mental math. You could obviously put this into a calculator, but if this isn't a calculator problem, you need to know that 64 times 1/2 to the 7th, that's 1/2 to the 7th. Right, you're just putting 1/2 to the 7th. That's going to be 64 times. And if you don't know 2 to the 7th, that's sort of fine. You can break it up. It's really 2 to the 3rd times 2 to the 3rd, right? Because you add exponents times 2 to the 1. So you can break it up like this, right? 3 and 3 and 1 get you 7. So it's 64 times 1/2 to the 3rd is 8, which is why I broke it up, because I personally know 2 to the 3rd. So it's 8 times 8 times 2. All right, that's 64 times 1/64 times 2. 8 times 8 is 64. All right, the 64s cancel out. So really what I'm left with is 1/2. So this whole thing is equal to 1/2. Right, and again, they asked me to solve the limit. That's really me just solving for the derivative. All right, let's do this next question. Let f be the piecewise linear function defined above. Which of the following statements are true? Okay, well, this is saying, actually, I'll write it out. What is this saying? This is saying the limit as h approaches 0 from the left. Okay, that means the derivative from the left is equal to the derivative, or derivative from the left is 2. That's what this statement is saying. All right, this statement is saying the derivative from the right is 2. And this is saying the derivative overall is 2. So that's differentiability from both sides. All right. Okay, well, let's see if that's true. So the derivative from the left, my left-hand function, left is f of x is 2x minus 2. That means my derivative is indeed 2, right? So this one is true. All right, from the right, f of x is equal to 2x minus 4. That means my derivative is also equal to 2, so this is also correct. All right. If the limit from the derivative from the left and the right is equal to each other, then it's almost differentiable. I just need to test whether it's continuous, right? Is it differentiability? Is it continuous for it to be differentiable? Well, from the left and the right, the left function is 2x minus 2. The right function is 2x minus 4. That's 2 times 3 minus 2 is equal to 2 times 3 minus 4. So that's going to be 4 is equal to 2. So it's not continuous, so it cannot be differentiable. So my answer choice is actually C. Actually, check your papers for this one, because I may have made a mistake in grading this problem. Instead of 1, 2, and 3, it is just 1 and 2 because not differentiable / no derivative. Not differentiable means there's no derivative because it is not continuous. Right? Hopefully that makes sense. All right. Cool. Let's take a look at this next problem. I'm going to go through these sort of quickly. The left-hand derivative, well, the left-hand derivative f of x is equal to x plus 2, which means f prime of x is equal to 1. So this is equal to 1. All right, that's A. All right, next B. F of x is equal to 1/2 x plus 2 squared, which means f prime of x is equal to, well, this is a chain rule, right? So I first take the derivative of the outside. The derivative of the outside would be 1x plus 2 to the first power. Right, you can see I did this power rule with the 2 and the 1/2. Test it out yourself. And I multiply by the derivative of the inside. Well, luckily the derivative of x plus 2 is just 1. So if you forgot to do chain rule here, you'd probably be in luck. So that's equal to x plus 2. All right. Well, x is equal to 0, so it's 0 plus 2. So my derivative is equal. My right-hand derivative is 2. Is my function differentiable at x equals 0? Well, my answer is obviously going to be no then. No, because the left and right limits of the derivative are not equal. Right? My left limit of the derivative is 1. My right limit of the derivative is 2. All right. Finally, we're going to go on to part D. All right. So if the function is differentiable, that means I know 2 requirements are met. Number 1, it's continuous, and also it is differentiable. Right. So if it's continuous, that means the left and right functions, or the left and right limits, are equal to each other. So that means I can set x plus 2 equal to ax plus b squared. Right. That's obviously I would write limits, but basically these two are equal to each other. All right. Differentiable means the derivative of the left. So the derivative of x plus 2 is just 1. Derivative a times x plus b squared, this requires a chain rule, right? So I first do a power rule for the outside. So it's 2a to the first power. I did derivative of my outside. The inside stays the same, so it's x plus b. Then I multiply by the derivative of my inside. Well, luckily the derivative of x plus b is just 1, right? Derivative of x is just 1. Derivative of b is actually 0 because b is a number. Cool, so that's my two equations. Let me simplify this. So it's 1 is equal to 2a times x plus b. All right, well, what do I actually know? I know x is equal to 0, so I can replace all the x's here with 0. That turns this to just 2. That turns this to just b squared. That turns this to just b. So if I were to simplify my equations, it's ab squared is equal to 2, and 1 is equal to 2ab. So we just have to solve for a and b, right? All right, well, how do I do that? I could just do some substitution. So let's say a here, when I solve for a is going to be equal to 1 over 2b. Right, hopefully you can see how I got that. I'm going to take this 1 over 2b, replace it in for this equation. Right. So 2 is equal to, well, a times b squared. Well, instead of a, I'm going to put in 1 over 2b and multiplied by b squared. All right, that means 2 is equal to 1 over 2. The b squared in the numerator and the b in the bottom means I'm left with just a b on top, which means b is equal to 4. All right, so b is equal to 4. If b is equal to 4, that means a is equal to 1 over 2 times 4, which means a is equal to 1 over 8. So let me erase that. So basically my answer choices are b is equal to 4, a is equal to 1 over 8. There we go. Those are my final answers. All right, hopefully that makes sense. Okay, next section here, we start studying some derivative identities and starting our derivative rules with the easiest one, which is power rule. All right, let's think about that. Power rule. All right, this one is easy, so I'm just going to do a quick f prime of x is equal to 3x squared minus 2x plus 1. So I plug in 2. So it's 3 times 2 squared minus 2 times 2 plus 1. So that's equal to 12 minus 4 plus 1. So that is equal to 9. My answer choice is B. All right, next question. Let f be the function given by, what is the instantaneous rate of change at x equals 3? Okay, well, remember, IROC is simply the derivative at a specific value. And what's the value? The value is at x equals 3. So let's solve for the derivative. So first I'll solve for the derivative, then plug in 3. The derivative is 3x squared minus 12x plus 8. I plug in 3. So that's 3 times 3 squared minus 12 times 3 plus 8. All right. Then I solve for that. So it's 27 minus 36. So I believe that's negative 9 plus 8. So that's negative 1. All right, my answer choice is C. Cool. Pretty straightforward and quick. Let's keep going. All right. So let's just do our product rule here and solve for this. Okay, this one took a decent amount of work. It's not that it's complicated. It's just if you mess up in the simplification, it can be confusing. So product rule. To have this memorized is simply VU prime plus UV prime. And you could have switched the order of these for product rule. It does not matter, right? So let's write out everything. U is equal to 5x. V is equal to square root of x squared plus 1. And if I want to make it simpler for me to take derivatives in the future, I'm going to do square root turns into actually to the exponent of 1/2, right? Those are the same thing. So actually, I'm going to just write it like this instead. All right. U prime is the derivative of 5x, so that's just going to be 5. V prime is going to be the derivative of this, which requires a chain rule. So it's going to be 1/2 x squared, or here, I'll narrate it step by step because it's chain rule. So it's 1/2 because I brought this 1/2 down. I'm taking the derivative of the outside, so the outside is negative 1/2, right? This is just a power rule. Remember, the inside I leave the same, so x squared plus 1 stays the same. Then I multiply by 2x. All right, cool. Now, just given that this looks really complicated here, I'm going to simplify it right here, so hopefully it makes it easier for me to solve. First, 2x times 1/2, that actually just turns into regular x. So it's going to be x times x squared plus 1 to the negative 1/2. Negative 1/2. Well, if something's to the negative exponent power, I can bring it to the denominator. So it's really x divided by x squared plus 1 to the 1/2. Right? I brought it down, so now it's positive 1/2. Additionally, something to the 1/2 power is the same as the square root. So square root of x squared plus 1. So this v prime is this fully simplified if I want to write it in square root form. And actually, I'll go back. I'll write this in square root form as well. All right, so I have my u, I have my v, I have my u prime, and I have my v prime when I fully simplify everything. Okay, then I plug it into my product rule. So my product rule is vu prime plus uv prime. So let's write that out. So my v is this. And I multiply it by my u prime, which is 5, plus u v prime. Well, my u is 5x. My v prime is this whole thing. Cool. Let's simplify this. So that just turns into 5 square root of x squared plus 1 plus, all right, 5x, I multiply by the numerator, so it's 5x squared. So instead of this, it's now 5x squared. Excellent. Cool. Final step is I'm going to plug in 3, right? They asked me for the IROC at x equals 3. So let's plug in 3. So that's going to be 5 square root of 3 squared plus 1 plus this thing, and I'm going to plug in 3 for all of this. So 3 squared, 3 squared. Okay. That turns into 5 square root of 10 plus 5 times 3 squared, that's 5 times 9, so it's 45 over square root of 10. Okay. Now I'm starting to look which one of these answer choices does that match with, and it is going to be answer choice D. All right, so a lot of work, mainly in the simplification and honestly in understanding square roots, not really in the product rule itself. All right, hopefully that makes sense. Next question. All right. The function above shows the graph of the function g and the line tangent to the graph of g at x equals -1. Let h be the function given by h of x equals e to the x times g of x. Where's the value of h prime of -1? So I want to find the derivative of h of x at x equals -1. All right, so let's find h prime of x. Well, first thing I notice, h of x is going to require a product rule, right? Because it's e to the x times g of x. So there's two functions. All right. So let me write out my product rule. vu prime plus uv prime. Excellent. Well, what are my u and v? Well, my u is equal to e to the x. My v is equal to g of x. That means my u prime is the derivative of e to the x, which is also still just e to the x. And my v prime is, if my function is g of x, that means the derivative is simply g prime of x. Cool, I'm going to plug that into my product rule. So v u prime, so that's going to be g of x e to the x plus uv prime, so e to the x g prime of x. And remember, this is at x equals -1. So I'm going to plug in -1 for each of these. So next step, I'm going to write this, and I'm going to plug in -1. So it's really g of -1 times e to the -1 plus e to the -1 over g prime of -1. All right, let's simplify this. Well, e to the -1 power, remember, if I have a negative exponent, what can I do? I can just bring it to the bottom, right? So g of -1 divided by e plus g prime of -1. And I can also divide it by e, because I'm just bringing these e's down. All right, let's continue simplifying this. What is g of -1 now? I need to actually find the value, right? Well, here's where my graph might come in handy. So notice they gave me the graph g. So g of -1, I simply go to -1, that's right here, and I find my value at g. So -1, my y value is 3. So it's going to be g of -1 is simply 3. All right, then I need to find g prime of -1. Well, you might say, I'm never given g prime, right? I'm given g of x. How do I find g prime? Well, remember, g prime is simply the slope at -1. So I go to -1, and I find the slope here. And they gave me the tangent line to the graph at g of -1. So that's great, because I can use that line to find the slope. And the slope of this line, well, how do I find the slope of this line? I'm just going to use change in y over change in x. My change in y is -6. It goes down 6, right? My change in x is I go from -1 to 0, so that's just change in x is equal to 1. So my slope is -6. So g prime is -6. All right. Well, 3 over e plus -6 over e, that's simply now -3 over e. So my answer choice is going to be B. All right, hopefully that makes sense. Let's move onwards to quotient rule. All right. This problem actually was sort of unnecessarily complicated, so I'm going to skip this one. So I'm going to say all of your problems here were okay. I actually didn't mark it wrong for anyone, so as long as you turn in your packet with the work for the other problems shown, you will be fine. All right. The function f is defined by f of x is equal to x over x plus 2. What points x, y on the graph of f have the property that the line tangent to f at x has slope 1/2? All right. So line tangent has slope 1/2. So what does that mean? We're putting this into words. Tangent line, instantaneous rate of change, slope, all those simply mean derivative, right? So, okay, line tangent has slope of 1/2. This means the derivative equals 1/2. So they're asking, where on this graph does the derivative equal 1/2? Well, let's find the derivative. The derivative requires a quotient rule, right? It requires a quotient rule because it's x divided by x plus 2. There's two functions divided by each other. So quotient rule is vu prime minus uv prime, all over v squared. Let's find my u, v. So u, v, u prime, and v prime. All right, in this case, my u, as I can see, is the top of the function, so it's x. My v prime is x plus 2. My u prime is the derivative of x, so it's 1. V prime is the derivative of x plus 2, so it's also 1. All right, I'm just going to plug that into my quotient rule. These seem really easy to plug in. So v u prime, so that's x plus 2 times 1 minus uv prime, so that's minus x times 1, all over v squared, that's x plus 2 squared. Cool, I'm gonna simplify this. So that simplifies, if you simplify this yourself, you should get just 2 over x plus 2 squared. All right, cool. So that is my derivative. Cool. And what do they say? My derivative has it's a slope of 1/2, so my derivative is equal to 1/2. So I'm going to take my derivative here, I'll write it down here, and instead of equal to 1/2, now I just have to solve for x, right? Solve for where does my derivative equal 1/2? Well, let's solve for x. I'm going to multiply both sides by this, so it's 2 is equal to 1/2 x plus 2 squared. I'll multiply both sides by 2 to get rid of the 1/2, so 4 is equal to x plus 2 squared. I'm going to square root both sides. So it's square root of 4 is equal to x plus 2, right? Now, square root of 4, remember it starts off like this. So square root of 4 is not only 2, it's plus minus 2, right? So it could be positive or negative 2 is equal to x plus 2. So I'm going to say I have 2 equations now. I have x2 is equal to x plus 2 or negative 2 is equal to x plus 2, right? All right, for one of the equations, x is equal to 4, or sorry, x is equal to 0, or x is equal to negative 4. All right, if you look at my answer choices, I could solve for the y values, but only one answer choice has x equals 0 and x equals negative 4, and that is going to be C. So C is the correct answer there. Right, all of these, this has x equals 4. Well, I know for a fact at x equals 4, I would not have a slope of 1/2 or a line tangent with a slope of 1/2 because I would have found that. All right, next question. What is the value of g prime of 4? Well, to find g prime, I require a quotient rule, right? Because I have 2 functions divided by each other. All right, so let's do my quotient rule again. VU prime, VU, all right, VU prime minus UV prime all over V squared. All right, U is equal to x squared minus 1. V is equal to f of x. U prime is equal to 2x. And V prime is equal to f prime of x. All right, so I plug it into my quotient rule. That means it's going to be squared VU prime minus UV prime. Well, my V is f of x. U prime is 2x minus U is x squared minus 1. V prime is f prime of x. Cool. And I'm going to plug it in at 4, right? It says where at g prime of 4. So I plug in 4 for all my x values. So it's f of 4 minus 2 times 4. So I'm going to turn that to 8. All right, 4 squared minus 1 is f prime of 4 all over f prime of 4 squared. All right. So let's actually, I'll simplify this a bit more. So it's 8 times f prime of 4 times f of 4 over 15 times f prime of 4 over f prime of 4 squared. Okay, I just have to fill in the f of 4 and f prime of 4's now. Well, luckily I'm given the graph of f. F of 4 is right here, so f of 4 is equal to 2. And f prime of 4, you'll say, I'm not given the graph of f prime, so how can I figure that out? Well, I'm not given the graph of f prime, but I'm given the graph of f, and f prime is simply the slope. All right, so the slope at 4 is 1/2. So f prime of 4 is 1/2. And you can calculate for the slope here. Could calculate for the slope. You would get 1/2. All right. So let's write let's just sub in everything. So f of 4 is 2. So it's 8 times 2 minus 15 times 1/2 over 1/2 squared. All right, so got 34. I feel like that's a different answer than what we had before. So I'll double check this, but the work there should be generally correct. So I will take the answer 34. All right, cool. If you have any questions, please let me know. Let's see. I believe I'm going to link the videos for the Unit 2 free response. Other people have done videos on this, and I'm probably going to try to see if I can splice it onto my video here. All right, so that is it for the multiple choice coverage.
Approximations. So the first thing we have to do is approximate w prime of 12. And that's going to be a difference quotient. So you go 1 to the left, you go 1 to the right. So w of 15 minus w of 9 over 15 minus 9. And that gives you, just reading off values from the table, that, which is approximately that. And then we need units. So the units of the numerator are degrees Fahrenheit, and of the denominator are minutes. And then we're supposed to interpret it. So that's the approximate instantaneous rate of change of W, which is the temperature of the water at T equals 12 minutes, is 1.017 degrees Fahrenheit per minute. And so the temperature is increasing. I mean, it's not like 100% clear to me what they want me to say on that. So that's my interpretation. And the next thing is I need to use the table. Okay, in this video we're going to talk about number 6 from the 2016 Calc AB exam, and it's kind of a problem where you're given a table and asked some very straightforward questions about it. So let's see if we can do this. So here's your table. It's got f, f prime, g, g prime. We're told that f and g have continuous second derivatives, and then we're just asked to do 3 things that you could probably do. Well, 2 of them you could probably do within almost the first month of calculus. So k of x is equal to f of x f of g of x, I should say. And when we want the tangent line at x equals 3. So we're going to need k prime of x. So k prime of x is f prime of g of x times g prime of x by the chain rule. And now we just need to plug in a lot of values. So to find k prime of 3, I like to show all my substitutions, like a lot of them. So f prime of g of 3 times g prime of 3. And now we need to start finding values. So the first thing I need is g of 3. So if you look at the table and find g of 3, that's 6. So I'm doing f prime of 6 times g prime of 3, which is 2. And then I need to find f prime of 6, which is 5 from the table. So it's 5 times 2, so it's 10. So k prime of 3 is 10. I need to find k of 3. So k of 3 is going to be f of g of 3. So I already know that g of 3 is 6, so it's f of 6. And then f of 6 is 4 from the table, so I get 4. It's a lot of table reading. So now it's going to be, I always use point slope, like always, unless they specifically tell me I need to rearrange it. So I'm going to go y minus 4 equals 10, the quantity x minus 3, and move on. That's part A. Okay, so the next part is telling me that h of x is a new function. It's going to be g of x over f of x. So I guess that's a small twist, because usually it's f over g, but g over f, and I need to find h prime of 1. So quotient rule. So it's going to be bottom derivative of the top minus top derivative of the bottom, and then all over the bottom squared. Alright, and now we're going to pick a lot of things out of this table here. H prime of 1 is f of 1, which is negative 6, g prime of 1, which is 8, minus g of 1, which is 2, that row's getting a lot of use here, f prime of 1, which is 3, and then all over negative 6 squared. And if we simplify that, we get negative 54 over 36, which is negative 3 halves, and that's the answer to that question. Let's move on.
This is number 6 from the 2013 Calc AB exam, and it is a separable differential equation problem. So first thing we're told is dy dx is e to the y times the quantity 3x squared minus 6x, and then everything we're going to do is about the initial, the particular solution that goes through the initial condition 1, 0. So the first thing we have to do is write the equation of the tangent line. So to do that, we're going to need to know the slope. So that means we need to evaluate dy dx at the point 1, 0. So I get e to the 0, substituting in for y, and then the quantity 3 minus 6, because x is 1, so it just becomes 3 minus 6. That gives me negative 3. And I also know it goes for the point 1, 0, so now I can write the tangent line. So y minus 0 equals negative 3, the quantity x minus 1. And then what I do is I'm told to approximate f of 1.2. So that's not very hard to do. What I'm guessing is they want to see an approximately equal to sign. Maybe know that you show them that you know you need to do that. So f of 1.2 is approximately negative 3 times 1.2 minus 1, which you could stop at, or you could go with negative 0.6. So 0.2 times negative 3.